Greetings everyone, you're welcome once more to MEPH, your YouTube channel where we solve problems of math topic by topic. Alright guys, so today we are going to be looking at a problem on the board. It's a word problem, but actually by the time we read through it and try to understand it, we can see that we can translate it into the problem on modularity. Okay, so the question says the circumference, of a circular track is 9 kilometers. A cyclist rides round it a number of times and stops after covering the distance of 302 kilometers. How far is the cyclist from the starting point? So one thing you have to note is when you come across questions that have to do with cycles, you can also think of what modular arithmetic, which we can also call the clock arithmetic. So for this problem, we have, let's draw the cycle, a solution, there's a cycle. So let's say the cyclist has this as the starting point. So he has to go round and round and round. So this is the start. Okay. So he has been able to what? Go round a number of times and stops after covering the distance of it. Now the idea is the whole of the cycle is 9 kilometers. So from this point, round, so if we go round the cycle once is what? 9 kilometers. So if we go twice is what? 18 kilometers. If we go the third time, we have is what? 27 kilometers. So he has been able to cover what? 302 what? Kilometers. So going once is 9 kilometers, twice is 18 kilometers, thrice is what? 27 kilometers. If it goes again, it's how many kilometers? We have 36 kilometers. Until he has gotten up to what? 302 kilometers. So at 302 kilometers, the question says how far is the cyclist from the starting point? It means at 302 kilometers, he moved a distance across the starting point. Okay, let's call that distance. Say this point. So this is how far. This is how far the cyclist has moved from the what? The starting point. So he has moved some distance far from this. So let's understand how many 9 kilometers are in 302 kilometers. So to simply solve this, we are simply going to what? Use modular. Okay, since we have the circumference of the circular track to be 9 kilometers, so we are simply going to set this in modular. So let's set this in what? Module 9. Okay, so we are going to set it in module 9. Just like you have your 12-hour clock, but this is now in module 9. So we are going to solve this in module 9. Whatever answer we get becomes how far the cyclist has moved from the what? The starting point. So how do we solve this in module 9? Okay. All right, it's very simple. We are just going to simply divide. I have 302 kilometers. So we're going to divide it by 9. So if we divide it, 9 into 30 is how many times? We have 3 times, which is 27. So 30 minus 27 will give us what? Okay, I have this as 10, which is 3. It's 2 minus 2 is 0, so it's 3. So I'm going to carry this 2 and put it here. So we have is what? 32. So 9 into 32 is how many times again? We still have is what? 3 times. Okay. So that would be what? still 27, so we have 32 minus what? 27. So I have this as 12. I remove 1 here, so to subtract this is 5. So we can see that he has moved what? 33 what times, okay? And how many kilometers left? We have 5 kilometers. All right. So 33 times and 5 kilometers. So remember in modular, whatever you divide, the remainder becomes what? So remainder what? 5 what? Kilometers. So remember in modular, whatever you divide, the remainder becomes what? The answer in that module. So 302 kilometers in module 9 will give us simply 5 kilometers module 9. So how far from this starting point is what? 5 kilometers. So that simply solves this problem. So he has moved, 33 times, okay, around the cycle and moved extra what? 5 kilometers. All right, so that gives us the solution to this problem. He moved what? 33 times around the cycle plus what? Extra what? 5 kilometers away from the starting point. Alright guys, make sure you hit the like button, okay? Leave a comment or two, share this video to your friends and students, and ensure that you subscribe to this YouTube channel. I will see you guys in my next video. Bye.